Hello everyone, this is Nilesh Gule here once again. In the last session, we had brief idea about C# data types. We talked about the C# primitive types, which are value types. And in earlier class, we already discussed about the C# classes, the user-defined reference types. Now it's time to take a look at the user-defined value types. And there are two user-defined value types. One is struct and another is enum. Let us begin with struct. Now that you are already aware with the classes in C#, let me tell you the structure in C# are similar. Meaning by the structure is also a user-defined data type. And in structure, we can again have the data members and we can have the member functions. We can create multiple objects of the structure. But don't forget that structure is a value type. Means when we are creating the local objects will be occupied on the stack and they will be having more efficient access. Structures should be primarily chosen over the classes when you want to go for the lightweight objects, where you do not want the complex OP level features, but you want to store the minimal data into the structures. One of the easy example could be a struct point, where you want to store maybe X, Y, and possibly Z. Another example I can give you is struct date, where you want to store some day, month, year like variables. So if you want some simple objects at that time, the structures should be preferred. Let me show you how we can create a structure in C#. So let me go back to the Visual Studio and we will create a new project. Let me name it as Struct Enums. Now inside this, I want to create a very simple structure like point structure. And inside this, I want to declare two data members. One is X and there is Y. By default, structure members are private. In C#, there is a convention that the private members are prefixed with underscore. This convention is well applicable to classes also. And as usual, I will write the private keyword explicitly for sake of readability. Now, the way we were writing the constructor in the classes, we can also write the constructor in the structure, which can initialize it to some default value. You may also go for a parameterized constructor where we can pass X and Y and those will be initialized to the data members. By the way, there is another interesting concept into the C# constructors. We can call one constructor from another constructor. If you see the code written in this constructor and code written in this constructor is almost similar, only the values are different. Then why we are rewriting the same code? Instead, can I call this constructor from this constructor? Yes, we can do this. This particular concept is called as constructor chaining, where you can call the constructor of the same type from another constructor of the same type. You can call a parameterless constructor from the parameterized or vice versa as per your choice. But for that, you need to prepare the constructor invocation using the colon. You need to use the keyword this and then you can pass the value 0, 0. Now, whenever a new structure is created, with a parameterless constructor, it will call the parameterless constructor, and that is internally calling the parameterless constructor. The value 0, 0 is passed in X and Y. Now, I'm not writing the similar code in both the constructor. This particular feature is exactly available in C# classes as well. Now that you have initialized the structure, let us go ahead and discuss about the properties. You recall in classes we return getter setter in smart way and we call them as properties. Can we write the properties in the structure as well? Answer is yes. You can declare the property something like this, where you can use the getter and setter part. And on the similar way, you can also write property for Y. Again, you can write the getter part, setter part. If you need any validation to be done inside the setter, you can do it. Again, value is a keyword which represent the value to be assigned to the given field. Now, another thing that we can implement is destructor. But the question is, can we write the destructor into the structure? Answer is no. This is a kind of a limitation or kind of a restriction you have for the structures. You cannot declare the destructor inside the structure. Also, you cannot use full-fledged OOP features like inheritance, polymorphism with the structure. If you want these all OOP features, you should consider using the classes. By the way, how I can create this point structure object? I can go ahead and I can make it point p1 is equal to new point. Please note that p1 is a local variable, and maybe due to the certain CLS norms, we are creating the object using new keyword. However, since struct is a value type, in this particular case, the p1 object is allocated on stack only. If you want, you may also write some display method inside this struct point, and in that I can quickly display the value x is equal to something and y is equal to something. We are using similar syntax as of earlier. Now we can display p1 dot display here. Let us make this as startup project and run this. As I discussed about the constructor chaining, you can take a look at that by putting the breakpoints. So let me set one breakpoint over here, another breakpoint over here, and I can have one more breakpoint over here. If I say F5, you will see that this is internally calling the parameterless constructor. And then that parameterless constructor is now calling parameterized constructor, which is doing this initialization, returning back to the parameterless constructor. Parameterless constructor will execute any further statements if written, and then the object is ready. And then p1.display method should display the expected output. Now, how I can call the parameterized constructor? Well, that can be done by point p2 is equal to new point, and you can initialize it with some values. Again, I can say p2.display over here, and you can check that it is printing x is equal to 2, y is equal to 6. Do you recall there was one more way of initializing the class object? Yes, it was using object initializer, and something similar can be done over here. Let's say I can create the object by using new point, and then in curly bracket, I can mention x is equal to 4 and let's say y is equal to 7. And then we can mention p3.display. Again, remember, in this below case, first the parameterless constructor is completed, and after that the setter x and y is called explicitly. That is wonderful. Now that we have seen that such simple things can be done using structure, understand that structure should be used only for the lightweight object, not for fully OP feature. A usual guideline is if you need some memory less than 16 bytes, then you can go for the structure. Otherwise, prefer to go for full-fledged classes in C#. Now, using basic C# structure features. There are some advanced structure features are also available. One is ref struct. This ref struct is designed to ensure that the structure objects are never created on heap in any circumstances. In other words, you cannot do the boxing of them. You cannot put it inside the array. They are designed to be created in the stack only. And that can be done by declaring a ref structure. Then the second concept called the read-only structure. The read-only structure is designed something like this, where you use read-only keyword before structure. Now, in such structure, you can have all the fields which are read-only. And if you are writing auto-implemented properties, then auto-implemented properties should have only the getter part. You may have the init part, but you can never have the setter part. I will give you one example of this. Let us consider that I have another structure, and here I'm talking about the read-only structure. Let's consider that this structure is a distance structure where I want to use feet and inches. So if you want to declare feet as a data member, and if you want to declare the inches as data member, then it should be declared as read-only. The read-only variables can be initialized only once in the constructor. You cannot modify them later. Instead of this read-only data member, what if you want to go for auto-implemented properties? Yes, you may go for auto-implemented property, and that can be done by writing public int, let's say inches. However, this auto-implemented property should have only the getter part. Moment you write the setter part, it will give me the error that you cannot have the setter part in the read-only structure. Well, you can have something called as the init part. The init part in auto-implemented property is talking about one-time initialization during the creation of the object, and it cannot be initialized later once again. Let me also write the property for this fit, and I can do it by using public int fit. I can write only the getter part. Writing setter part is again not allowed for the read-only part. However, you may again go for init, where you want to initialize fit to the given value. This init is another special property syntax which is very much applicable for the properties inside classes as well. Now, how I can create the object of this distance? Let me create the object of distance in another main function, where I can create distance d1 is equal to new distance. And by default, over here feet will be 0 and inches will be 0. But you might think of initializing them using the object initializer, like is equal to new distance, and then I can consider passing feet is equal to something and inches is equal to something. Please note that this feet and inches call is not for the setter part, but it is the call for the init part of my properties, right? That is wonderful. If you want, you can also write the parametric constructor for one-time initialization. On the similar line, you can write the display method and you can call them. You must have noted that once these objects are created, you cannot modify them later. For these purposes, you should be going for the read-only structure. There is third advanced concept for the structures, and that concept is talking about the record structure. The record structure is a quick and easy way for declaring the structure members, especially the data member, and it will automatically create the constructors and ToString equal method for you. How we can do that? Let us have again another quick demo. Let me again declare one simple record structure, which can be declared as a record struct. Let's say example is date. But now I will simplify this. Directly, I will use day, month, and year, which will act more or less like the auto-implemented properties. You can create the object of the date directly. So let me give a try into another main. Now inside this, I can have date d1 is equal to new date. And by default, yes, they are initialized to 0, 0, 0. But I can use this object initialize syntax and I can set day is equal to 1, maybe month is equal to 1, and maybe year is equal to 2026. On the similar line, I can create another date where I can say day is equal to 1, month is equal to 1, and then year is equal to 2025. Good. Can I try to print this D1 and D2 directly? Let me give a try. C1 console.writeline D1 is equal to D1 dot ToString. Let me run this and cross check. Can I print this? Please note that I have not written anywhere ToString method, but this ToString implementation is done automatically for me. This is automatically generated for all record structures. On the similar line, I can also have D2. Not only that, are my D1 and D2 are equal? Well, I can check whether they are equal or not by using equal to operator. Now again, I have not written equal to operator anywhere, but for record structure, these equal to operators are automatically implemented. Equal to along with not equal to. Let me just put a message that D1 and D2 are same. Or otherwise, I can put a message D1 and D2 are different. Let us run this. Great. D1 and D2, these are two different ones. Now, these are few important concepts regarding this record structure. If you at all want to write your own method inside this particular structure, you can go ahead. Please note that this day, month, and year, all three will be directly accessible inside your all methods in that structure. So inside this, I can write it 0, maybe 1, maybe 2, and let's say we can write day, month, and year. Good. Now you can try to display one of that. Let's say D1 dot display. Yes, that is working well. So here we talked about certain advanced concept or special concepts about the structure in C#. Let us have a quick look at the structure versus class. Typically, the structure should be chosen when you want really small object less than 16 bytes. For the larger objects, please go with the classes. Second thing, the structures, they are said to be equal based on their value, based on their state. While the object references, you can compare only the addresses by default. I'm talking about the equal to operator. Now, let us talk about allocation. Since structure are value types, when the local structures are created, they are allocated on the stack in spite of using new keyword. However, the new class name will always create the object on the heap. In the structure, we cannot write the destructor. In the class, we can write the destructor. The structure cannot be used for inheritance, but any structure can be inherited from some interfaces. The class inheritance is allowed, and class can also be inherited from the interfaces. Now that you have enough idea about the structure, let us go for next example about enum. So basically, what is enum? Enum are nothing but the readable constants. So instead of using hard-coded constants 1, 2, 3, 4 in my application, I can go for some readable names, readable label for these constants. I will give you some example. Let's say this is enum weekday. And in this enum weekday, I want to write, let's say Sunday, Monday, Tuesday, Wednesday, we can add Thursday, Friday, and then Saturday. Good. Now, I want to tell you that all these Sunday, Monday, Tuesday, Wednesday, these are internally referred as integers. As you can note, they have given the numbers based on their position, also called as ordinal number. And by default, the first constant is numbered as 0. The next constant will be 1, next constant will be 2, next constant will be 3, and so on and so forth. If you want to check these values, I can put a main, and inside a main, you can declare a variable of enum, that is weekday d1 is equal to weekday dot Monday. This is a straightforward way of initializing it. If you want to print it, let us go ahead and try to see what is stored in this. You can just check d1 and run this, and you will see that yes, it is displayed as Monday, which is label of your constant. But if you want to print its number, yes, you can also print its number, and that can be done by typecasting it to the integer. Because as I said, enums are internally stored as integers, int, which is occupying 4 bytes. Great. What if I want that instead of storing it is a int, it should be stored as short or byte value? Yes, enum are always the integer constant. So instead of int, you might write short, or you might write byte. This is a typical inheritance syntax which is telling me that weekday is now inherited for byte. So each and every member will occupy only 1 byte. Anyway, let me keep it default. Now, can I initialize this weekday with some other value, like integer value directly? Let us give a try. Let's say d2 is equal to 5. If I'm trying to do it like this, it is giving me the error that directly I cannot initialize. However, you can use the explicit casting, and then this initialization is very much allowed. Now you can go and check that D2 is equal to D2. You should be able to see that the 5 is nothing but the Friday. So over here, it will print Friday. And if you want to print the number related to that, let me also print it over here. You can check that. Now, this gets you into the new question. What if you assign something entirely wrong number there? Let's say I'm going for D3, and in D3, let's say I'm putting some number, let's say 21. Now, in this enum, there is no 21 number position. If there is no 21 number position, what will happen? Will it give me any error? Answer is no. It will not give me any error. But at that time, since there is no label exist for that, you can check it is considering the number 21 as a label also. This is a strange behavior, but this is how the enum work. If you have initialized it to the 0, then you can see it that it is Sunday. So either you can use enum with the labels, or you can use enum directly with the numeric values. You can also think of using enum into the switch case constants. Now that you've seen the basic default behavior of the enum, we can go ahead and we can talk about another example. Let's say I want to declare a enum color, and at this time the color that I want to declare over here, I want to put some random colors, but I want to see if instead of using 0, can I use some other values. So let me put some values, let's say red, green, blue, maybe yellow, maybe black. I'm just putting some colors at random. I guess those should be enough. Now the question is, what will happen if instead of starting with 0, I want to make it 4? Is it allowed? Answer is yes. Now the red is numbered as 4. Automatically, green will take the next number, let's say 5. If you wish that you want to modify certain number later on, yes, you can go ahead and you can modify that number. Now red is 4, green is 5, blue is 2. The next number will be again 1 plus the previous, that is 3, and the black will be maybe 4. If you want, you can also assign the negative value. Let's say, for example, I'm putting a value -3. Now what will happen? In this particular case, this is -3. So this will be -2. This will be -1, and so on and so forth. Please make a note that certain values may get duplicated as well. As you can see in this example, red is 4, and you can see blue is 2, yellow is 3, and black is also 4. If both are the similar number, is it allowed? Answer is yes, it is allowed. But in this particular case, do not consider using that enum into the switch case, because switch case will give you the error about duplicate case. Well, we can give a try on this color and try to print these values quickly. So let me declare another main, and inside this, let me try the color, let's say C1 is equal to. What will happen if I assign 4 to this? As you have already seen, the 4 is duplicate for red as well as black. In this particular case, which value will be considered? My observation is that by default, it will consider the first value. That is nothing but the label red is counted over here. Let me give a try. I'm also printing the position of this is an integer position. Let us run this, and you see that it has taken as read 4. Please note, this can be a bit troublesome if the constant values or labels are repeated. Better you avoid it, but somehow this feature is possible. Now that you have understood how these enum work or what are the intricacies of the enum, let me tell you the easy and most common way of dealing with the enum. Typically, we use enum for some menu-driven programs. Let's say I want to declare a menu. Maybe my menu is exit, my menu is add, subtract, multiply, and divide. So can I access it into the main? Can I display the menu? Yes, you can. And let me go to the main. How I can access all this constant? Now you need to first understand that each enum is inherited from the predefined enum type, and that predefined system.enum type itself is inherited from system.value type. So if you want to get all the labels in this enum, you should be using that base class enum dot get values, which will return me the array of the enum. But which enum? You need to pass the type of that enum, and that type of enum you can get it by using the type of operator. The type of operator can be used with any user-defined or predefined type to get the type, get the metadata about that particular type. We will discuss about the type of in detail when we will go for the reflection. For time being, you understand that this get values returns me the array of menus, and then we can access all the members of that one by one using for each loop, where I want to print each menu. But apart from the menu, I want to also display the ordinal number. How I can display the ordinal number for each constant? I guess you know you can do it by typecasting it to the integer. And then I'm using like this. Let me run this, and you will see that all the enum labels and their positions are displayed. Great. Now that you have shown display menu to the end user, let us take the input from the end user. How we can take the input from the end user? Let me ask end user that enter choice. And based on user's choice, let's say choice is equal to convert dot to int32, and inside bracket we can use console dot readline. Good. Now this choice over here is an integer, but we want to use it as a selected menu option. Can we do that? Yes, very well. We can declare menu is equal to choice. Only thing we need is typecasting. And then you can go ahead and you can put a switch case, and inside a switch case we can give m, and inside this you can have access to all the cases one by one. So let's say I have the first case, let's say add. Currently I'm just printing one simple option called, let's say that add option is called, and you can use the break. Similar way I can write the case menu dot subtract, and again I can write the message, let's say the subtract case is selected. On the similar way you can write the multiply, and I can specify that the multiply option is selected by the user, and at the end we can have the case divide. By the way, like C, C++, and Java, here we can also have the default case. And the default case is typically executed when none of the earlier case is matched. Of course, you can write the default case anywhere in the sequence as per your choice. And I can simply say it is unknown option selected. And yes, you can write the break once again. That's it. Let us give a try if it is working. Let me select option 2. And yes, the subtract is selected. You can run it once again. Maybe I'm giving option 4 and you find that yes, divide is selected. If at all user put entirely different choice, yes, the default case is executed. This is one of the common use case of enum. You will see the enum into some of our next applications like thread state and few more. Today, we primarily discuss about the structure and enum as a user-defined value types in C#. I hope you find this useful. We will talk about the next C# concept in the next video. Thank you very much. Bye-bye.